Okay, so in this session, we look at November 2011. It's a limiting factor question. So here we have two constraints. We have to test and see which one is actually the limiting factor. You may have more than one constraint, but your level, we don't do linear programming again. Usually when you have two or more constraints at the same time, we use linear programming. But because of your syllabus requirements, now we won't do linear programming. We just do single limiting factor questions, okay? So let's look at this question. It tells us that what a company is located in the free zone enclave and is faced with resource constraints. As a result of the technical nature of its operations, the monthly labor hours are limited to 175,000 hours. The supply of raw materials has also been adversely affected by recent climate change, who has promised to supply 60,000 units of materials monthly. Details on the product are as follows. Okay, so they've given us the various details. Now it is telling us that advise management of the most profitable production mix, which is your profit maximizing output, right? And ascertain the most optimum profit expectation if the fixed cost of the month amount to what? 240,000 Ghana cedis. So with this scenario, the same way, you identify the limiting factor. And when it comes like this is where students have a problem. So let's first see, identify what? Identify the limiting factor. So I told you always, this is what you do. So what do you do? Let's test. So now look at the one which they've given you limitations of. It tells you that what the demand for the products are this. So they've given us the demand for the various products, right? They've given us the demand for the various products. So let's look at the limitation that we have. So it says that what labor hours are limited to what 175,000 hours. That means there's a limitation, it's a constraint. Also, the supplier can only produce supply 60,000 of materials. That means materials is also limited. So what do we do to check if we actually have what limitation? So let's check material, right? Check material. That is my approach. So I say check material. Check material kgs. So let's check and see if material kg is the limiting factor. So available for production will be how much? Available for production. Material kg available for production. It says that it is 60,000 what? Kgs. I'm just assuming it's kgs, right? It's 60,000 units or 60,000 kg. But how much is required for production? Okay, so they've given us here that direct materials required per unit is down here. They've given it to us already. So once it is there, we need to test and see, right? So most of the time, if direct material cost per kg was given, right, we can divide this direct material cost per unit by the cost per kg, right, to get the units required. Some questions are like that. But this one, they've given us the units that are required, the material requirements per unit, which is the kgs required. So actually this is kg, this is direct labor hours per unit. We already know. So let's try and see. So for product A, we actually need 3 kg, but how many units are we producing? The question, it tells us that A, we are producing what, 10,000 units. So that means you actually require what? 30,000 kgs. When we get to product B, it says we need what? How many kgs? We need 2 kgs, but we are producing what? 6,000 units. That means what? We need 12,000 kgs to produce. When we come to C, it says C, we also need 2 kg. I'm picking the figures from here. You can see these are the figures that I'm picking up, right? 2 kg. That we are also producing what? It gave us the units 10, 6, 12,000, and 8,000. That means now I'm producing 12,000 units. Also for this guy, that means I need 24,000. Also, when I take product D, I need 3 kgs, but I'm producing 8,000 units. And that is also 24,000 kgs. So when I put all together, the total materials that I need for production plus 24,000 plus 12,000 plus 3,000. That means we need 63,000 kg. And also 63,000 kg, but we only have 60,000 available. That means that what? There's a shortage of what? Of 3,000. Meaning material is the limiting factor, but don't end there because max might be allocated for testing labor as well. So let's shift this up. Let's try labor. So check labor hours. Okay, let's check for labor hours as well. So checking labor hours, what is the hours available for production? Hours available for production is how much? So labor hours, we have 175,000 hours available. That's what we have, right? So in that case, how much do we require for production? So requirement for production for labor hours. So how much do we require for production? So for product A, it tells us that we need 5 hours. This is where I'm picking the figures from, labor hours, you can see. So we need 5 hours, but we are producing what, 10,000 units. That means we need what, 50,000 hours to produce. When we get to product B, it tells us we are using 4 hours each, but we are producing what, 6,000 hours. That means we need 24,000 hours. For product C, it tells us how many units are we producing. For product C, we need also 4 hours, but we are producing 12,000 units. That means we have 48,000 hours. And then for product D, we need 6 hours, but we are producing 8,000 units. That means we also have 48,000. Also, if we put all together, what do we have? So we have 50,000 plus 24,000 plus 48,000 plus 48,000. That gives us 170,000. That means that there's a surplus or slack, okay? Which means it's unused. Slack means unused resource, okay? So that means there's surplus hours available. That means labor hours is therefore not the limiting factor because it has an excess hours or it has excess hours available. So your conclusion, I get it. So your conclusion from the analysis is that material quantity, which is kgs, is therefore the limiting factor, okay? That's the first thing you do to get your max. Now that I know the limiting factor, I must work everything in line with the limiting factor, okay? So now that I have the limiting factor, the next step is to get my contribution per unit as usual. So step 2 is to find my contribution per unit, right? So my contribution per unit, I have product A, product B, product C, and product D. So take my selling price, 60, we have 60, we have 45, we have 50, and we have 65. So let's get our variable costs also. Variable costs. So for variable costs, I have what? Direct material to be 15, 10, 10, and 15. We have direct labor to be 20, 16, 16, and 24. We have variable overhead to be 12, 8, 10, and 11. Also, so we know sales minus variable cost or selling price minus all variable costs should give us our contribution per unit. So that's one of the most important concepts in management accounting, your contribution per unit. So let's deduct. We get our contribution per unit. Also, so contribution per unit, what then do we get for each? So we have 60 minus 15 minus 20 minus 12. which ends up giving us 13 for product A, assets contribution per unit. Then we come to product B, 45 minus 10 minus 16 minus 8. And that gives us 11 for this product. We come to product C, which is 10 minus 16 minus 10. We end up with what? A loss contribution. That's 50. Sorry, I didn't take out the 50. We have 14 assets contribution. Then we have 65 minus 15 minus 24 minus 11. Also giving us what? 15. That means we need what? Our contribution per limiting factor and also. So the next step is to get what? Contribution per machine material kg, right? Because that's the limiting factor. So contribution per material kg, I just have to divide this 13 by what? The material kg. This one we divide by 3 kg. We divide this by 2 kg. Divide this contribution by what? 2 kg as well. And divide this by 3 kg. Okay. So that means our contribution per limiting factor for product A is 13 divided by 3. 13 divided by 3. And that gives us 4 cedis, 33 pesos per kg. When we divide 11 by 2, we end up with 5 cedi 50 pesos per kg. We have 14 divided by 2. That gives us 2 cedis, 7 cedis per kg, sorry. And 15 divided by 3, that's 15. That's 5 per kg. Not so. Now we know that when we are ranking, this guy takes first, this guy takes second, this guy takes third, this guy takes fourth. So we are going to use this ranking to prepare our optimum production plan, right? So my next step will be my ranking also. Step 4, rank. So I know I have first, second, third, and fourth. And also, now that I have this, I can prepare my optimum production plan. Also, or profit maximizing output, which is my first step. So production what? Plan. You see, I didn't use the labor hours because it's not the limiting factor. So available kgs. So available kgs is what? We actually require what? 60,000 what? Kgs for production. Also, if we require 60,000 kgs for production, we take the product, also we take its rank, and we take its use or utilization. So which one was first in ranking? I think it was product D. Which was first? A product what? C, sorry. C was first in ranking. How much materials do we need? We needed 2 kg, but we are producing what? 12,000 units. That means, can we use all the 24,000 kgs from the 60,000? Yes, we can. So how much do we have remaining? We have 36,000 kgs remaining. Then which one was next in ranking? It was what? Product B. B was next in ranking, so this is second. And for product B, how many material kgs did we need? We needed 2 kg. I'm picking from here, right? We needed 2 kg to produce. So if 2 kg to produce, how many units would we expect to produce? We're producing 6,000 units. So 2, 6, we need 12,000 kgs to produce this 6,000 units overall. Still, we can take it. We can produce how much is left? We have 24,000 hours remaining. This 24,000, which one was next in ranking? I think product D was next in ranking. It was third in ranking. So that one, how many We need 3 kg, not so, and we are producing how many units? 8,000. That means we can utilize all the 8,000 units. We can produce all. So when we take this out, we have nothing left. I get it. So kg is available. That means we can't even produce even 1 unit of product A. We can't. We don't have the luxury of kgs or luxury of material to do that. So if possible, if it's still needed as a brand product or something, we can outsource. We can outsource to an external supplier. But realize the case, our profit maximizing output doesn't have A, right? We can produce all except A. So the next step is to get what? Our maximum possible profit, right? Our maximum profit, which is straightforward here. So get your maximum profit. So what's our maximum profit? We need our contribution. We know profit is contribution minus fixed cost, right? So we take our contribution, and what will be our contribution? So when we take product, what? A will not be there, so A, 0. We couldn't produce any. Product B, we require, so we have 2 approaches. I didn't say it earlier. You can use your contribution per unit multiplied by the unit, or you can use your contribution per kg and multiply by the kgs you got. It's all the same. You still get the same answer. So we'll try the 2 alternatives. So let me call this M1 or method 1. So if I take A, we know the contribution for A. What did I get for the contribution? That means I have to go up again to look at the contribution. 13, 11, 14, 15, 13, 11, 14, 15, 13, 11, 14, and 15. So now that you have this, you can just multiply by the units. This one, we produce 0 units. We couldn't produce any. For B, we could produce all the 6,000 per our budget or our production plan. We could produce all the 12,000 for C, and we could also produce all the 8,000 for D, not so? So we get it. We have 66,000 contribution for this guy. 14 by 12 is, it should be 168, right? That's 4 plus 2, 6, 4 times 2, 8. So 14 by 12, yes, 168,000. Then 15 by 8. That's 120,000. Okay, so this is our total contribution now. So if we add up, that's 66,000 plus 168,000 plus 120,000. That gives us 354,000. 354,000 also. And this is our total contribution. Now I less the fixed cost, not so? Less fixed costs. And in the question, it told us that what our fixed cost was 240,000. So take out your 240,000, and that ends up giving you your maximum possible profit. So 354 minus 240,000, that gives you 114,000. So 114,000 becomes what? The profit. Okay. So that is it. The same way, if you want to go with the second method, let's go and capture our contribution per limiting factor. We have 4.33, 5.5, 7, and 5. Let me just write them somewhere so that I can remember instead of scrolling. So I think this one was 4.33. This guy was 5.5. This guy was 7. This guy was 5. So I've written them down. Now we can scroll, go down to the next method. We are still going to get the same maximum profit. Let's try that and see. And the hours that we have, I think, let's also get the hours down. Sorry. These are the hours. Okay. So I think for A, we didn't produce anything at all. So the hours, I should say the hours for A are still 0, right? Then when it comes to B, the hours that were required was 12,000 hours, for C 24,000 hours, and for D also 24,000 hours. So we've got this down. Now let's try to use it to get our profit. We can still use it to get the same maximum profit that we have here. So let's see. So maximum profit, right? So you see the first one was per unit. So we multiplied by unit. This one is per kg. So we multiply by kg. So A, we know A, the contribution per kg was 4.33 per kg, but we couldn't produce any kgs, so it's 0. Now, when we come to B, we made 5 cedis, 50 pesos per kg, and we were expected to produce 12,000 kgs. Okay, so we have 5.5 times 12,000 kg. That gives us 66,000. Did we get 66,000 for the first one? I think so. Then when we come to C, we made what? 7 cedis per kg. Not so, but how many kgs? It was 24,000 kgs. So we do this. We have 7,000 kg, 7 by 24,000 kgs actually. So that gives us 168,000. I think we also had that, not so. So you see here, I'm using the contribution per the limiting factor by the production hours or production kgs, which is based on the production plan. So I think this was 5 per kg also. And I think we are producing 24,000 kg, or we are using 24,000 kg of materials. So 5 by 24,000, that is 120,000 also. If we add everything here, 120,000 plus 168,000 plus 66,000, that gives us 354,000. Also 354,000 as our total contribution. Then less our fixed cost of 240,000 also, and that gives us what? Fixed cost. So that still gives us our 114,000 as our maximum possible what? Profit. So that is it. Now let's come to the concept I said I'll bring on, shadow price. Now, if we say shadow price, that is that if I should add an extra kg to the 60,000 kgs available, not so. If I should add one extra resource to the limited resource, what extra contribution will be generated? I get it. What is the extra contribution? So 1 kg should bring an extra contribution. What is the extra contribution that will be got of the limiting factor, right? Well, you can work everything and you still come and get it. But then straightforward, you can say that the extra contribution, also, or the shadow price is still equal to what? The contribution per the limiting factor. And what was the limiting uh, 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 the limiting factor, or the limiting why is the English not coming? The limiting product. Let's try and let's see what I'm talking about. What becomes the extra contribution that you get? Let's see. So now I'm saying that what the available kgs is now what? 60,001. Not so. It's now 60,001 kgs. And required for production, we know the requirement for production, we calculated it earlier. What did we get? I don't want to work it again. I just want to do an experiment for you to see. The requirement for production, where is it? We calculated it somewhere. Okay, 63,000. Okay. Was 63,000. Was 63,000. That means you have what? 3,001 kg shortage. Okay. It still becomes a limiting factor, even though you add an extra unit to it, right? So what then happens then? If you everything will still remain the same, despite your production, is the production capacity that you have to check and see how much it affects your production plan. So if we are still doing our production plan, now look, that means that our available kgs is now what 61, no, it's 60,001 kgs available, right? This is actually 60,001 kgs available. Then when we take the products and their ranking, we know C is the first in ranking, right? So if C is the first in ranking, I'll come and give you a short way of doing this. If C is the first one in ranking, also which is first, we actually needed to produce what? We needed to C. We needed 2 kg and we're producing 12,000 units. So we needed 24,000 also. So that means that we were left with 36,001 also kg. When we come to the next in ranking, which was B second, we needed what? Also 2 kg, but we were producing 6,000. So we take out 12,000. You see, you will still be left with what? 24,001 kgs remaining. If I take D, which is what? Third in ranking, I also needed 3 kg. I was producing what? 8,000. You see, I end up with what? 24,000 and what? 24,000, meaning the remaining kg, the remaining kg is what? Is 1 kg. And if 1 kg, that means that 1 kg can only produce what? How many units of what? Product A, right? Which is the last one in ranking. So if I have 1 kg, 1 kg, how many units of product A can it produce? You get it? And that means that since I require, well, how many kgs do I require for product A? I require what? 3 kgs and I have only 1 kg available. So this 1 kg over the 3 kgs should give me what? 0.33333 units, right? It means that it can produce one kg can produce what? 0.3333 units. So this 0.3333 units, what extra contribution does it generate? What extra contribution does it generate? So the extra contribution it generates is actually what? The contribution on A, which is what? This 0.3333 units times the contribution per unit, which is how much? For A, its contribution per unit was, what did I write down for their contribution? Sorry, I need to be scrolling. A's contribution per unit was actually what? 13. So this by what? By 13. Okay. And that gives us what? The extra contribution for this product, which is 0.3333 by the 13. And that's how much? 4.3. Okay. Now that gives you 4.3333 as the extra contribution. Now you can tell me you've seen this 4.333 somewhere. Have you not? Yes. So this 4.33 that we see here, which is the contribution per limiting factor, for the one you cannot produce or you are limited of, the one which is less profit making becomes the shadow price. So instead of going through the process I went through to get the shadow price, you can just look at the one you can't produce most of, or the one that whatever will be left you use to produce, and then the contribution per limiting factor for that particular product becomes the shadow price. So you see I've still got a 4.33 for A to still be the shadow price. So instead of going through this long process, you can just take the contribution per limiting factor of product A to be your shadow price. So that brings us to the end of limiting factor decisions, where we'll do throughput, where we'll still utilize the same approaches, but I'll teach you how to use throughput analysis in decision making. Then we can start with short-term decision making techniques.